All right, so this is practice problems for section 1.2, fractions. So you should have tried these on your own first, and you can check your answers here. If you haven't tried them on your own, I would suggest you try them before you watch the video here. So finding the prime factorization of a number, 184, means to break it down to prime numbers, and we do that using the tree, which we practiced in the lesson. So I need to figure out two numbers that multiply to make 184. The most obvious to me is 2 times 92. And I circle this 2 because it's prime. I don't need to break that down anymore, but 92 is also divisible by 2. 2 times 46. Again, 2 is prime, but 46 is not. So we're going to break it down to 2 times 23. 2 is prime, and 23 is also prime, so we're done because we have only prime numbers now. So we can express 184 as 2 to the third power times 23, or 2 times 2 times 2 times 23. You don't have to use the exponent. I just used to save space here. All right, on number 2, we're going to find the prime factorization of 212. Using the tree again. 2 times 106. 2 is prime. 106 is 2 times 53. And 2 is prime. The big question now is 53 prime. It's not divisible by 2. It's not divisible by 3 or 4 or 5 or 6 or 7 or 8, which leads me to believe it is prime. So 212 is equal to 2 times 2 times not 20. Let's see if I can erase that. Yeah, there we go. 53. All right, so we're going to do some practice problems. Simplify. If you remember the concept, any fraction that's the same in the numerator and the denominator is equal to 1. Any fraction that has 0 in the numerator is equal to 0. Any fraction that has 0 in the denominator is undefined. You can't divide by 0. Simplify. A fraction simply means to reduce it. So if we're starting with 20 over 36, I can reduce it quickly by dividing the numerator and the denominator by a common factor. So the largest number that I can think of that goes into 20 and 36 is 4. So if I divide them both by 4, 20 divided by 4 is 5. 36 divided by 4 is 9. So 20 over 36 is equal to 5/9. Doing the same thing on 120 over 300, simply reducing. The first step to reducing this is to cross off these zeros. When you do that, you're just dividing them both by 10. And we're left with 12 over 30. Now I'm going to divide 12 and 30 by a common factor of 6. They're both divisible by 6. 12 divided by 6 is 2. 30 divided by 6 is 5. So 120 over 300 is equivalent to 2/5. We're going to reduce 21 over 70. The largest number that I can think of that divides evenly into both of those is 7. 21 divided by 7 is 3. 70 divided by 7 is 10. So 21 over 70 is equal to 3/10. All right, we're going to convert mixed numbers to improper fractions. To convert a mixed number to an improper fraction, we first multiply and then we add. So 3 times 1 is 3, then we add the 2, makes 5, and that becomes the numerator. 3 times 1 is 3, plus 2 is 5. The denominator is always the same. So this turns into an improper fraction of 5/3. Same thing on 5 and 4/7. First multiply. 7 times 5 is 35. Then add the 4. 35 plus 4 is 39. The denominator stays the same. So 5 and 4/7 is equal to 39/7. 3 and 1/5. Multiply, then add, we get 15/16. The denominator stays the same. So 3 and 1/5 is equal to 16/5. All right, we're going to do it the other way. We're going to convert improper fraction to a mixed number. To do that, we divide. The numerator, the top, 8, divided by the denominator. So 3 goes into 8 twice. That's going to be our whole number. Multiply back. 2 times 3 is 6. Subtract. The leftovers become the numerator. The denominator is the same as what we had. So 8/3 is equal to 2 and 2/3. 80 divided by 7. 7 goes into 8 one time. Subtract, bring down. 7 goes into 10 one time. Multiply, subtract. The leftovers become the numerator. The divisor is the same. So 11 and 3/7. 123/6. 6 goes into 12 twice. When I multiply and subtract, there's no leftover, so I bring down the 3. 6 doesn't divide into 3, so I'm going to carry a 0 up here. And that means my leftovers are 3. So that's the numerator. The denominator is 6. However, 3/6 is not reduced. They're both divisible by 3. So 3/6 reduces to make 1/2. So 123/6 is equal to 20, the whole number here, and 1/2. The 3/6 reduces to 1/2. Okay, so here we have the next page of fraction questions. We're going to start with some multiply. To multiply fractions, we multiply top times top, bottom times bottom, and then of course we reduce if we can. 2 times 3 is 6 in the numerator. 5 times 7 is 35 in the denominator. 6/35. 6 and 35 don't have any common factors, so there's no reducing need to happen there. On number 16, we can actually cross cancel before we multiply, and that just makes the reducing faster. 5 and 25 have a common factor of 5, so when I divide 5 by 5, 25 divided by 5, and 3 and 9 have a common factor of 3, so I divide them both by 3. And now I have some new numbers which I can multiply. Across the top, 5 times 1. Across the denominator, 3 times 1. And it's okay to leave it as an improper fraction, unless the directions tell you to change it to a mixed number. Okay, to multiply mixed numbers, we have to first change them to improper fractions. So we just practiced that on the last page. Multiply and add. So 2 times 2 is 4, plus 1 is 5. 5/2. 5 times 3 is 15, plus 3 is 18. Before I multiply, I see that I can cross cancel. These have a common factor of 5, so I divide them both by 5. These, 2 and 18, have a common factor of 2, so I divide them both by 2. And then when I multiply across the top, 1 times 9, 1 times 1. And of course, this simplifies to make just the whole number 9. All right, to divide fractions, don't forget you keep, change to multiply, and flip the second fraction. So we're going to keep the 3/7. We're going to change, divide to multiply, and we're going to flip the second fraction. If we can cross cancel, we will at this point, but there's no common factors on the diagonal here. So now we multiply 3 times 6 across the top, 7 times 5 across the bottom, and we get 18 over 35. Number 19, same concept, keep, change, flip. So we're going to keep the first fraction, change to multiply, flip the second fraction. But this time I see that the 40 and the 8 have a common factor of 8. They're both divisible by 8. So when I divide by 8, this is what I get. And now I multiply the new numbers. 9 times 1 across the top, 5 times 5 across the bottom. Gives me 9 over 25. Just like in multiplication, you cannot divide mixed numbers. You have to first change them to improper fractions. So multiply, then add. 7 times 5 is 35, plus 5 is 40. So we have 40 over 7. I'm going to keep the divide for right now. Multiply, then add. 7 times 2 is 14, plus 6 is 20. Now I follow my rules for division. Keep, change, flip. So keep the first fraction, change to multiply, flip the second fraction. Look for any cross canceling. These have a common factor of 7. So when I divide them both by 7, I get this. These have a common factor of 20. So when I divide by 20, I get this. Now I multiply the new numbers across the top. 2 times 1 is 2. Across the bottom, 1 times 1 is 1. This simplifies to make 2. All right, find the least common denominator of 18 and 24. Okay, to find the least common denominator of 18 and 24, we're going to write them as prime factors, and you can use the tree on these if you want to off to the side. When you break down the 18, you end up with 2 times 3 times 3. When you break down the 24 to prime numbers, you end up with 2 times 2 times 2 times 3. The least common denominator has to have all of those factors in it, so we look for the biggest group of 2's. Here, there's a group of 2's, but there's only 1 2 in it. This group of 2's is bigger, so we're going to take all 3 of those 2's, the biggest group of 2's. Same thing with the 3's. There's a group of 3's here, but there's only 1 3. This group is bigger, so we'll take that group. When we multiply all those together, we get the least common denominator. I'm going to multiply them kind of short. I know that 2 times 2 times 2 is 8. I know that 3 times 3 is 9, and I know that 8 times 9 is 72. So that's the least common denominator of 18 and 24. All right, we're going to add fractions. 2/7 plus 4/7. To add fractions, they have to have the same denominator, and the denominator of your sum will also be the same number. So I know there's going to be a 7 in the denominator. To add or subtract fractions, you just add or subtract the top, the numerator. So 2 plus 4 is 6. So this turns out to be 6/7. Same concept here in subtract on number 23. The denominators have to be the same, so I know the denominator of my answer must be 15. I'm going to subtract the numerators. 9 minus 4 is 5. However, now, this fraction can be reduced because 5 and 15 have a common factor of 5. So we're going to divide them both by 5, and that leaves us with 1/3. All right. Now we have some subtraction here without common denominators. I like to figure these vertically, rewrite this vertically, because it's easier for me to see what I need to do to change the denominators. I need to change this denominator to a common denominator. The smallest number that 12 and 8 will both divide into is 24. So the common denominator will be 24. Now that I've changed the denominators, I also have to change the numerators. So this is the tricky part, determining what multiplication happened between the old fraction and the new. So to get from 12 to 24, I would multiply times 2. 12 times 2 makes 24. Whatever that multiply is, I also have to do the same thing on the top. So I have 7 times 2 making a new numerator of 14 here. On this fraction, 8 times 3 is 24. So on the top, also multiplying times 3. 3 times 3 is 9. And now I can subtract. Of course, the denominators are already the same, so I know the denominator of my new fraction is going to be the same also, 24. I subtract the numerators. 14 minus 9 makes 5. So this is 5 over 24. All right, we're going to add mixed numbers now. We have 2 and 4/15 plus 3 and 6/25. There's actually 2 ways to do this. A lot of people like to go ahead and change these to mixed numbers and add them that way. I never practiced it like that, so I just always leave the whole numbers and convert the fractions to a common denominator. The common denominator for 25 and 15 is 75. That's the smallest number that 25 and 15 both go into. And you can figure that out by writing out the prime factors and then choosing the biggest group of each factor like we practiced above. All right, so now to change the numerators, I have to know 15 times what makes 75. So 15 times 5 is 75. So the new numerator is going to be 4 times 5, or 20. 25 times 3 makes 75. So the new numerator is going to be 6 times 3, which is 18. And now I'm ready to add. I'm going to add the fractions first. The denominator will be 75. 20 plus 18 is 38. I'm going to add the whole numbers. 2 plus 3 is 5. So I have 5 and 38/75. Nice fraction there. 26 is a subtract. We have 10 and 1/6 minus 8 and 11/20. In subtraction, sometimes the best course of action is to change them to improper fractions, or you're going to end up having to borrow sometimes. So I'm going to go ahead and change them to improper fractions. Don't forget, multiply, then add to make an improper fraction. So 6 times 10 is 60, plus 1 is 61. The denominator is always the same. 20 times 8 is 160, plus 11 is 171. The denominator is 20. All right, we need a common denominator now. The common denominator for 6 and 20 is 60. 6 times 10 is 60. 61 times 10 is 610. 20 times 3 is 60. 171 times 3 is 513. Remember, no calculators. Write it off to the side and multiply it out. All right, we're subtracting. So the denominators are going to stay the same. The numerator, we just need to subtract 610 minus 513. 610 minus 513 is 97. So that's your final answer, 97 over 60.